In the last topic, we have covered phases of design, different parameters required for machine design, and the aesthetics and ergonomics consideration for development of new product. In this topic, our main aim is to achieve the course outcome. Course outcome is select suitable material for designing machine element. Selection of proper material for machine element is one of the most important steps in the process of machine design. The best material is one which will serve the desired objective with optimum cost. It is not always easy to select a material, and manufacturing process may involve trial and error method. The following factors should be considered while selecting the material. First, availability of materials. Second, material should possess the important property to fulfill the requirement of machine element and working condition in service of the machine. Another factor, that is, for every application there is a limiting cost beyond which the designer can not go. In cost analysis, there are two factors: cost of material and cost of processing material into finished good. Let us see important properties of material. Mechanical properties of material are those which are associated with the ability of the material to resist mechanical forces and load. The first property is strength. It is the ability of material to resist externally applied force without breaking. Second, stiffness. It is the ability of material to resist deformation under stress. Modulus of elasticity is the measure of stiffness. The third important property is elasticity. It is the property of material to regain its original shape after deformation when external forces removed. This property is desirable for material used for tool. As you know, steel is more elastic than rubber. Fourth property, that is plasticity. It is the property of material which retain deformation produces under load. This property is essential for forging and stamping on element. Next property, that is ductility. It is a property of material enabling it to be drawn into wire with the application of tensile force. It is generally measured in percentage elongation and percentage reduction in area. Next property is brittleness. It is just opposite to ductility. It is a property of breaking of material. These material, when subjected to tensile load, snap off without giving any elongation. Cast iron is the best example of brittle material. Next property, that is malleability. This property permits to be rolled, hammered into the sheet. Malleable material should be plastic, but it is not essential to be so strong. Soft steel, wrought iron, copper, aluminium are malleable materials. Toughness. It resists fracture due to high impact of load like hammer blow. Toughness of material decreases when it is heated. This property is essential where parts are subjected to shock and impact load. Next property, machinability. This property relates with which a material can be cut. Machinability can be measured in different way. That is, tool life for cutting tool, thrust required to remove material. Next property, resilience. It is the property of material to absorb energy and to resist shock and impact load. Creep. If material subjected to constant stress at high temperature for longer period of time, it will undergo a slow and permanent deformation, which is known as creep. This property is useful for selecting material for IC engine, boilers and turbines. Fatigue. When material is subjected repeated stresses, it fails at stress below yield stress. Such failure is known as fatigue. Fatigue can form crack. This property is to be considered in designing of shafts, connecting rod, springs. Hardness. It is an important property of metal. The main property is resistance to wear. Sometimes deformation also. It has an ability to cut another metal. Let us see designation of material. A large number of varieties of steels are used for machine component. Therefore, steels are designated by group of letter or number indicating carbon content, tensile strength or composition of alloying element. Let us see first the designation of plain carbon steel. For example, 20C8. This carbon steel contains 0.15 to 0.25% of carbon and 0.6 to 0.9% of manganese. Let us see another example of alloy steel as shown on the slide. 40Cr 4MO2. It's an alloy steel. The 40 indicates the average 0.4% of carbon. Chromium is 1%. Molybdenum is 0.2%. In this designation, the first figure indicates 100 times average percentage of carbon. Alloying element multiplication factor is shown on the table. For chromium, it is 4. When chromium has multiplication factor is 4, therefore 1% chromium is present in the alloy. Similarly, molybdenum has multiplication factor is 10. For 0.2% molybdenum is present in this alloy steel. Let us see high alloy steel. For example, X10 Cr18 Ni9. Letter X indicates high alloy steel. Figure indicates 10, that is 100 times the average percentage of carbon content. Thus, carbon percentage is 0.1. Chromium is present 1.8% and nickel presents 9% in this high alloy steel. Cast iron are designated as their types and tensile strength. For example, FG150. FG stands for grey cast iron and 150 stands for 150 megapascal. Its tensile strength. WM350, where WM indicates white malleable cast iron and 350 MPa gives its tensile strength. Similarly, BM300, where BM stands for black earth malleable cast iron and 300 MPa is its tensile strength. Similarly, PM450, where PM is the pearlitic malleable cast iron and 450 is the tensile strength in megapascal. Then we'll go to the another type of cast iron, that is SG400 by 15. SG stands for spheroidal graphite cast iron. 400 MPa is the tensile strength of this cast iron and 15 indicates 15% elongation. As we have covered composition and properties of material, now we shall discuss about manufacturing processes to be used for manufacturing component while designing. Knowledge of manufacturing process is of a great importance for design engineer. Let us see different processes. The first process is shaping process. Shaping means the forming the shape of component such as casting, forging, bending, shearing. Second process, that is machining process. It is nothing but the process used for giving final shape to the component such as turning, drilling, boring, milling, broaching. The third process, which is known as surface finishing process. This process is used to provide a good surface finish such as buffing, honing, lapping, electroplating. Next process, joining processes. These processes are used to join components. They are welding, riveting, soldering, pressing, screw fastening. And the last process, the process affecting the change in properties. These processes are used to impart certain specific properties so as to make the component for particular operation or application. These processes are heat treatment, cold working, hot working, and short pinning.